In this example, we're given the graph of a rational function, and we're going to break down exactly how to find the function itself, that rational function that's going to create this graph. It's really not that bad, but it takes a few steps. So bear with me on this. The first thing we're going to look for are zeros, or roots, or x-intercepts. Those are going to affect the numerator and produce factors for us there. All right, so zooming in here to our graph a little bit, it looks to me like we only have one place where the graph touches the x-axis. And it's going to be right here at 2. All right, so with that x-intercept, let's go ahead and identify it as we have an x-intercept at 2. And the factor that's going to go with that is going to be, it's always x minus whatever the 0 value is. So it's going to be x minus 2 in our case. All right, next up, what we want to do is see if we can figure out what the multiplicity is going to be on this 0. All right. So how we determine that is we say to ourselves, okay, the graph was on the top of the x-axis, above the x-axis until we get there, and then we come back the same direction. Some people call this a touch. Others call it a bounce when we get to that x-intercept. But in either case, whatever you call it, it's going to mean that this is going to be an even multiplicity. All right, so what we're going to do is just go ahead and say it's probably going to be an even multiplicity. We're going to aim for 2, smallest even number going on there. All right, so as we're building up our function over here on the side, our numerator is going to include an x minus 2 with an even multiplicity, and multiplicity of 2. I'm going to go ahead and put that up here in our exponent. That's where the multiplicity is going to be located. And in fact, let's try to color code this a little bit. That multiplicity of 2 is what made that exponent into a 2. All right, next up, the denominator. The denominator is going to be built up by first identifying where our vertical asymptotes are on this graph, and then figuring out kind of similarly what factors go with those, and then what their multiplicities are going to be. All right, so back to our graph. It looks to me like we have 2 vertical asymptotes illustrated here with dashed lines. We have one at -2, and then another one at +4. All right, so over here, let's go ahead and identify, we said -2 and +4. Very, very similarly to how we built up our numerator and those factors there, it's always x minus whatever value we just identified. So x plus 2, x minus a -2 means x plus 2, and x minus 4. Next up, figuring out their multiplicities. All right, looking at our graph, what we can see is as we get close to our vertical asymptotes, let's see what happens to our graph. So on the left-hand side, when we get close to -2 from the left-hand side, our graph goes down. So it's on one side of the x-axis. It's on the bottom side. And then on the right-hand side, if we trace our graph in close, it goes up. So because this is on opposite sides of the x-axis, one goes down and one goes up, what that tells us is this is going to be an odd multiplicity. All right, this is going on opposite sides. Very similarly to if a graph crossed the x-axis at a 0 or root or x-intercept. If we had an x-intercept and we approached from the top and we crossed, this would also indicate an odd multiplicity for an x-intercept. Now we didn't have that on this one, but that's what it tells us as far as our vertical asymptotes go, and what, for lack of a better term, we would say is their multiplicity, the power that factor is going to be raised to. Now let's look over here at 4, another vertical asymptote. As we approach from the left-hand side, we go up, we're above the x-axis. If we trace the graph from the right-hand side, you'll notice it goes up as well. So we're on the same side of the x-axis. So what that tells us is we're on the same side. That tells us we're going to get an even exponent for this one. All right, so as we think about this, we said multiplicity on the one at 2 was going to be odd. Let's just go with 1 for its exponent. And then an even multiplicity at 4, let's go with 2 for its exponent. All right, so now our factors, these factors go in the denominator, x plus 2 times x minus 4 quantity squared. Well, we've got a great start going on this, but there's one other thing we have to be careful of. It could be that there is some sort of scalar multiple, a constant, being multiplied out in front here. So to illustrate that, let's use A, that's the most typical letter used, and let's identify one additional point on our graph. So zooming in a little bit here. Typically, it's easiest if we find the y-intercept. All right. You could use another point. It should work out also. But what if I said, let's find the y-intercept as a general rule? All right, our y-intercept looks to be right here because our units, this is going to be 1. I believe our y-intercept is at 1/2. So that's going to go as the ordered pair 0 left or right, up 1/2. Well, that's an x value, and that's a y or f of x value. So let's use those values and plug them in to our function we're creating on the right-hand side. So f of x can be replaced with positive 1/2. We still don't know what a is. We're going to find that in a second. We're going to replace our x with 0. So 0 minus 2 quantity squared, all over 0 plus 2, and then 0 minus 4, again, quantity squared. All right, that leaves us only with the one unknown. We don't know what a is, and everything else is numbers. So solving down for a shouldn't be too bad. So we're going to bring the 1/2 along. We're going to go ahead and say, well, that's a times negative 2 squared. We have positive 2 and negative 4 quantity squared here. So really, this is going to be 1/2 comes down one more time. A times 4 over 2 times 16. Just kind of taking our time order of operations as we simplify this down. So we're working on solving for a. So that's going to be 1/2 equals a times 4 over 32, which we can reduce down a little bit on the right-hand side. We can say that's 1/2. 4 over 32 means the same thing as 1/8. And the a can be in the numerator or it could be off to the side, doesn't really matter. To find a, one more step here, we're going to have to multiply by 8. So it looks to me like when we have 8 times 1/2, we're going to get 4. And a is going to be left on the right-hand side all by itself because we multiplied and divided by the same thing. So the last step is we're going to take this value of a. We're going to go back to our function we were building up here at the top. And we're going to replace the a with 4. So again, say final answer, f of x is going to be 4, plugged in for a, times x minus 2 quantity squared, over x plus 2, times x minus 4 quantity squared. Now don't forget about the a, plugging in one additional point, and then solving down for a, plugging it back in. All right, hope this helps out as you're working on finding the equation of rational functions graphs. Good luck.